All right, so the recording has started. So let's dive into today's lecture. Okay. Now, today, what we're going to start with is we're going to start with another very, very interesting classifier. It's a very powerful classifier called decision tree. Okay. And I think like we will spend the next couple of lectures on decision tree. So this classifier is something that we are going to spend some time in, and we're going to look into this classifier very, very carefully. But mind that this is a very, very powerful classifier, and it's a very useful classifier. Okay, so we're going to look into this classifier now. Okay, it's called decision tree. So far we have looked into 0-hour classifier. Okay, and we have looked into 1-hour classifier. Now today we are going to look into another classifier called the decision tree classifier. Okay, so let's have a look at what is this about. Okay, first of all, understand it's a classifier. So because it's a classifier, it's going to do classification. Okay, all right. So what's the classification problem? In a classification problem, you have a collection of records, okay, or a collection of instances, right? Nakina, clear? Okay, so you've got a collection of instances which we would call the training set. Okay, so whenever you're going to use some data set, you know, to train on you're going to use a classifier, okay, and you're going to train using that classifier on a particular data set. The data set on which you're going to do the training will be called the training set. Is that okay, Nakina? Yeah. So imagine we have a collection of records or collection of instances. That is, we have a training set. Okay. Now each record means each instance is characterized by a tuple x, y. So it contains two things, x and y. What is x? X is an attribute set and y is a class label. Remember, whenever we are going to write this as xy, okay, the notation is you have to write it as capital X followed by small y, because x contains more than one attributes and y is usually one attribute. Okay, right? All right, one target or one label that we would like to classify. Now if you do not write it with capital, the other notation is you can still write it with a small x, but in that case you have to put it in a bold font. Okay, that's just a mathematical notation. Okay, right, because x is a vector here. Okay, are we good so far, Nakina? Is that clear?
Yes, sir.
Okay, so each record will be characterized by a tuple xy, where x is an attribute set and y is a class label. Now there are a lot of names that we give to x. Sometimes we will call x as attributes. Okay, sometimes we will call it as predictor. Maybe you have heard in the last class or last class we spoke about we mentioned that as predictor. Okay, sometimes we will call this as the independent variable. Sometimes we'll call this the input. Sometimes we'll also call them the features, right? Yes, Nakina, clear? So these are the different names that we give to x. Okay, and what is y? Y is the target class that we would like to predict. So this is a class, it's a response variable, dependent variable, output, whatever you want to say. Sometimes we also mention it, we also say it's a target, clear, that we would like to predict. Is that okay, Nakina? Clear?
Yes, sir.
Yeah. Now, what happens when we train a, let's say we use a training set, okay, to train up a particular, we use a training set and we apply a particular algorithm, classification algorithm on the training set. It creates a model, right? And what does this model do? The model basically maps the attribute set x to one of the classes y. So what really happens? What does the model do? Model somehow creates a map, and we're going to talk about this mapping that it's going to create. So what does the model do is, you have got different x's. Okay, so these are the different inputs, x1, x2, up to, let's imagine, xn. So how many features do we have in this? Yeah, how many features do we have?
3.
Sorry,
3 features.
I can't hear you. So can you say it louder?
3 features.
n features, right, Nakina,
Oh.
right? So you take n features, and what is it going to do? It's going to predict a y. So basically, takes all these feature values and maps it to which value of y should it belong to. Am I clear, Nakina? Is that okay?
Okay, sir.
Yeah. So that's basically the job of a classification algorithm. Okay. So the model will be mapping the attribute set to one of the class labels y. Is that okay? Right, Nakina? So far, so good?
Yes, sir.
Okay. So now we would like to see, okay, so let's give some examples here. Some examples that you already know from previous classes would be like, what about if we have a task of categorizing email messages as either a spam or a non-spam email? So what's your label? Your label could be either spam or it's a non-spam message. Am I clear, Nakina? Okay. So the email message that you have is either a spam or non-spam. Is that clear, Nakina?
Yes, sir.
Yeah. And what are the attributes that you can look into? Well, there are different features you can look into. For example, you can look into message header. You can look into content. You can look into who has sent it. These are the different features you can look into, and then you can finally classify it as either a spam or non-spam. Is that okay, Nakina? Right?
Yes, sir.
Okay. So what happens is, if you are actually carrying out this problem, what your machine learning algorithm do is it's going to take a number of features. Okay. And each of these features, when you're training them, could be different things. For example, it could be the sender's email address. It could be, the subject. Okay. It could be the message header. It could be the content, and you can do other. You can analyze the content. You could extract some other features from there. And once you create a good model, what it should be able to do? It should be able to predict a y. And this y can be either a spam or a non-spam. So for any email that you have, so this is an email. What you do is you extract the features. So you extract the features. This is extracting the features. And once you extract the features, and if extract features and you supply the features to this one, okay, to the model, it should be able to predict whether this email message that you have is a spam email message or a regular email message. Am I clear, Nakina? Is that okay? Yeah? Okay, sir.
Yes, sir.
Right. Other examples of classification tasks could be, identifying tumor cells. So you could actually have an X-ray or MRI scans, okay? From the X-ray or the MRI scans, okay? You can extract different features of the tumor cells. You can look at different things about tumor cells. Maybe you can look at the shape of the tumor cell, size of the tumor cell. You can know the location of the tumor cell, okay? There are other patterns you may look into, right? And then what your machine learning algorithm would do is it would either classify the tumor cell as a malignant tumor cell or maybe a benign tumor cell. Is that clear, Nakina? That's another classification task. Is that okay? Yeah?
Yes, sir.
Another example of a classification task could be, you can extract telescopic images, okay, right? And then from the images, you could classify the galaxy as either an elliptical galaxy, spiral galaxy, or irregular shaped galaxies, or things like that. Okay, so that's basically classification task. So what happens in a classification task? In a classification algorithm, or in any typical classification algorithm, what we have is, first of all, we need to have some data, right? Now, from the data, we need to know the features. That means we need to extract the features. Am I clear, Nakina? Okay. Now, once we have the features there, now those features are these X's. The set of features that we have are these X's. Clear, Nakina? And then in the algorithm, what we do in the training set, okay, so we are doing supervised learning. So for each X's, we know the corresponding Y in the training set. So the classification algorithm will learn from this, training set, okay, the map that we have, okay, or the way we can model these X's to this corresponding Y, right? So When we train that, the model will learn how to map these x's to the corresponding y values, right? Then if you want to really, test it, you can test it on a test set. So you can give a new let's say instance, and extract the features, input the features to that, and the model will tell you for this input set, this is the y value that you should have. Am I clear, Nakina? Is that okay?
Yes, sir.
Yeah. Right, so that's the idea. So what's the general approach for building a classification model? Now, I just explained you the general approach, but let me just explain that same thing in a more, in a very simple, with a very simple diagram, okay? So what happens is you've got a training set. Can you see that? You've got a data set, that's the training set. So let's say you are training a particular, let's say you're training on this with this training set, okay, using a particular learning algorithm to create a particular model, okay? So anyway, let's look at this one. How many instances do we have in this training set?
10.
10. The number of instances that we have in the training set is 10 in this example, right, Nakina? Is it a good amount of instances? What do you think?
No.
No, it's not. But let's say for this example, we have got 10 instances. So we have instance. So the training set has a size of 10. Okay, right. Now have a look over here. We have got some features over here. What are the features we have in the training set? Can anyone tell me? What are the features we have in this training set?
Homeowner.
Homeowner.
ID.
Marital status.
Annual income.
Right? And you want to predict if this particular person is going to be a defaulter borrower or not. Okay, let's say he has taken some money from a bank, and you want to predict whether this person is a defaulter or not. That's what you want to do, right? So basically your task is to looking into the user profile. You want to figure out if this particular person is going to be a loan defaulter or not. Now, how can this one help the bank? If the bank provides a model like that, how can it help the bank? Now, the way it can help it is because it's like if you have a new applicant who is looking to borrow, some money from the bank can use this model to predict whether this new client the bank has, whether the new client will be a defaulter borrower or not. Okay, that will motivate the bank to either give the loan or not to give the loan. Okay, right, Nakina? Clear? Is that idea okay? Yeah.
Yes, sir.
So for instance, okay, we'll come to that later, but it's okay over here. Now, as we are talking about the features, now you have said the features to be homeowner, marital status, annual income, right? Somebody also said the ID. Can ID be a feature?
No, sir. ID,
No, sir.
ID actually is not a useful feature.
Label,
right?
label.
It's just a way to actually identify a particular instance. That's it. Okay, but is it a useful feature? It is not a useful feature. Am I right, Nakina? Yeah.
Yes, sir.
So your feature set here are homeowner, marital status, and annual income. So that's your feature set X. So these are your X's. Am I clear, Nakina? Okay, so I will not consider this as the feature set in the feature set, right, Nakina? I will not consider this in the feature set. Am I okay so far, Nakina?
Sir, ID যদি ইউনিক হয় তাহলে তো সেটা ফিচার হতে পারে।
কোনটা কি?
ID যদি ইউনিক হয়, লাইক
ID তো ইউনিকই হয়। তোমার NSU ID এবং আরেকজনের NSU ID কি সেম হবে? হবে না। ID তো ইউনিক হবে, but can it be a feature? That's my question.
না স্যার, আমার মনে হয় এর ইউনিকনেসের কারণে এটা ফিচার হচ্ছে না।
Exactly, that is correct. ঠিক আছে? I mean, like say for example, I want to predict, the grade that one student would get, ঠিক আছে, depending on different features. Do you think your NSU ID can be a feature in this one? Does your ID value affect what grade you get? No. Your ID is simply going to, it's simply going to identify you. Your ID is going to tell who you are, but it is not a useful feature, right? Other things that can affect the grades will be the features, but ID here over here is not a feature. So it's very important that what are you training against, okay? Is it okay, Nakina? Are we all okay with that ID should not be ideally a feature? Is that okay to everybody, Nakina?
Yes, sir.
Yeah, okay. So the training set that we have are for homeowner, whether he or she is a homeowner or not, what is the marital status, and what's the annual income. Okay, right. So these are your X's, and what you want to predict, whether he's going to be a defaulter borrower, defaulter or not. Okay, so that's the Y that you want to predict. Is that okay, Nakina? Clear? Yeah. Okay. So Y over here, Y এর value কি হতে পারে in this? Can you see? Look at this and tell me what are the possible values of Y.
Yes and no.
Yes and
no. So either you're a defaulter or you're not a defaulter, right? Yes and no. Clear, Nakina? Yes. Okay.
Yes, sir.
And X, what are the features you're looking at?
homeowner,
Are you a homeowner or not? That's one feature you're looking at. You're also looking at the marital status of the individual, okay? Marital status of the individual. And you're also looking at the annual income of that particular person in question, right, Nakina? Annual income. So these are features. So what are features? Features are important things that can affect the Y value, which is whether he's a defaulter borrower or not, right, Nakina? Yeah. So for example, ID ব্যাপারটা আমি আরেকবার একটু বলি. Let's say for example, I want to detect whether a person is a male or a female. So I want to detect gender, okay, using different features like ধরো face recognize করে I want to detect whether he's a male or female. So let's say face থেকে I can take different features. Like for example, I can figure out the position of your eyes, the nose, the shapes, the eyebrows and stuff like that. These are the different features I can take up. So এটার সাথে কি তোমাদের NSU ID-টা কেউ ঢুকানো যাবে? Let's take NSU ID as well to detect whether it's a male or a female. That's not a useful feature, right, Nakina? Clear? Yeah?
Yes,
sir.
Yes,
Right.
sir.
So that's what's important to realize, Shekunta, which one can be a feature or which one cannot be a feature. Another way to look into is this, ID is unique for everybody. So that's not a feature. Feature has a set of values. Let's say homeowner. He's either a homeowner or not a homeowner. Marital status, single, married, or divorced. So it has some particular values. Of course, there are other features which could be continuous values like annual income. So this is a continuous value, right, Nakina? Okay, but that's a useful feature. Am I right, Nakina? Clear?
Yes, sir.
Yeah. Okay. So far so good. Okay. So what we do? What's the general approach for building a classification model? So we have a learning algorithm. Okay. Right. So we're gonna discuss about one algorithm today. So let's imagine we have a learning algorithm. Okay. And what we do then is we use this learning algorithm and we apply this learning algorithm on this training set. Right? Think it now. Okay. So when we apply this learning algorithm on this training set, it learns certain things about this data and creates a model of that. Is that okay, Nakina?
Sure.
ঠিক আছে? How does it learn it? We will see an example. Don't worry about that. But basically what happens is you have got a training set and you've got the learning algorithm. So you apply the learning algorithm on this training set, and what it does, it learns a model and it creates a model. Right, Nakina? Yes? Is that okay so far?
Yes, sir.
So we create this model using which data set?
Training data set.
Using the training set or using the training data set, okay? And you apply a particular classification algorithm on that particular data set, okay? Now, when you have this model, what does this model contain? Now, when you have this model, when it builds that model, now this model knows, okay, this model has somehow learned how to map X to Y. So the model has learned how to map these X values to the corresponding Y value. So this is what model has learned, okay? So that if you give the model these X values, let's imagine these X values, okay, it should be able to predict what would be the corresponding Y value. Is this clear, Nakina? Is that okay?
Yes, sir.
Good. So once you have developed a model, you want to evaluate the model. You want to know how well the model is doing. So if you want to evaluate the model, should you actually test the model on the same training set data? Ideally, we should not, because we already developed the model using this training set. So we just want to see how well does it evaluate on a data set it didn't see before. Is that clear, Nakina? Yeah?
Yes, sir.
And therefore, we have a new data, we have another data set called the test set over here. So this is a test set data. So we have got some X values and we do not know what's the corresponding Y values. Let's imagine these are our new customers, potential customers who has applied, to the bank for a loan. Okay. So the bank wants to, predict, shall the bank actually, give the loan to these instances, to the IDs 11 to 15, right? So should the bank do that? So what can the bank do is now it can take that model, okay, right, that you have developed, and then it applies this model on these test sets. So when you say, when I apply the model, that means I give the value of X, and when I give the value of X, what will this model predict? What will the model predict? If I give the values of X, what will it predict?
Y.
Y. And the value of Y could be either yes or no. And that's how you know, well, this should be either yes or no. Things like that. Is that clear, Nakina? Yeah?
Yes, sir.
So that's the basic idea for any classification model. So when we develop the model, okay, we apply the learning algorithm on which data set? On the training set.
Training data.
Is that okay, Nakina? And when we want to evaluate the model, maybe we will evaluate the model on a data set that it didn't see before. Is that right, Nakina? Yeah? That's where the real test comes in. Nakina, clear? Are we good?
Yes, sir.
Yeah? Okay. Very good. Okay. It's like giving a real exam. Okay. So you're solving some problems. Okay. All right. And you're learning about a subject. And then when you finally give the examination, okay. All right. You get a question, okay, with similar problems that you have learned, but not exactly the same question. So we want to see how well are you doing when you are given a similar problem, but not something that you have seen before, right? Okay, it's the same idea that we're using here. Is that clear, Nakina?
Yes, sir.
Yeah. Now, one more thing. When the model is learning, this is called the induction. Okay. So when you are using the learning algorithm to, develop the model, this process is called induction. Okay. All right. This technique is called induction. So induction means it now learns the model from examples, from instances, from data. Clear? That's induction. And this one is simply deduction, because you're using the model to deduce what should be the corresponding Y value. Is that clear? That's the deduction, when you're applying the model to deduce what's the target variable. Is that okay?
Yes, sir.
Am I okay with everyone, Nakina? So far, so good?
Yes, sir.
Okay. So far, so good. Now, it turns out that there are different learning algorithms. Learning algorithm policy, you can use different learning algorithms. It turns out that there are different learning algorithms. In fact, you can build your own learning algorithm. right, Nakina? Okay. But before we build our own learning algorithm, let's learn some existing learning algorithms. Okay. So some of the basic classifiers that you would see include decision tree learning algorithm. So that's one, classifier. In the next few classes, we will be talking about decision tree classifier. So decision tree is a classifier that will, that will do the classification task. Then there are rule-based classifiers, and you've seen some rule-based classifier. What rule-based classifier did you see?
Um,
1R.
0R and 1R.
Okay, 0R actually it's not even fine. You can say rule-based. Rule-based.
1R.
Yeah, 1R and 0R, they are rule-based classifiers, and we have seen them. Then there are some classifiers that depends on the nearest neighbors that we have. One of the famous classifiers is called the KNN classifier. We will talk about this. Okay, don't worry about it now. That's called the K nearest neighbor classifier. Okay, there are probabilistic classifiers like naive-based classifiers, Bayesian belief networks. Then there's a classifier called support vector machine. Then we have got neural networks and deep neural nets. These are examples of some of the basic base classifiers that we have. Is that okay, Nakina? Yeah. We also have some classifiers which we call them as ensemble classifier. Okay. So ensemble classifier means, okay, we are going to, not just use one classifier, but we are going to use a number of classifiers, and we're going to, fuse them to make a decision. Is that okay? So basically, ensemble classifier consists of a number of classifiers, and somehow we fuse them to make a decision. Is that okay, Nakina? Is that clear? So in case of ensemble classifier, do we use a single classifier to make a decision, or do we use multiple classifiers to make a decision?
So we use multiple.
We use the multiple classifiers to make decisions. A very good example of ensemble classifiers is a random forest algorithm. We will talk about ensemble classifiers as well further down in this course. Okay. So there are different classifiers, and each classifier has its own algorithm, has its own strategy to actually make a prediction. Is that okay, Nakina? Now, today we want to discuss a particular classifier. The classifier we are interested in is called the decision tree classifier. Okay, so we want to know how can we use this decision tree classifier to make a prediction. Is that okay, Nakina? Okay. Now, coming to the decision tree classifier. Now, remember, I would like you to remind you that this is the training set we were talking about, right? So in this training set, how many instances do we have?
10.
Again?
10.
10 is
10 instances. How many features do we have?
3.
3 features.
Three features, okay? And there is only one target class that we would like to predict, okay? All right. Now, you see over here, homeowner, this is a categorical variable, right, Nakina? Isn't it a categorical variable? Because the values are either yes or no. So this is discrete or categorical variable. Marital status is also a categorical variable or a discrete variable because the values are single, married, and divorced, nothing else, right, Nakina? So this is discrete. Am I right, Nakina?
Yes, sir.
But annual income is not a discrete variable. It's not a categorical variable. It's a continuous variable because its value can be anything. Clear, Nakina? Is that okay?
Sir.
Yeah. So that's what we have. Acha. Before we look into how does a decision tree make the classification, decision tree kiভাবে কাজ করে, before we look into that, let's see what does a decision tree look like. So what happens is if you are training, using this training set, okay, and if you're using a decision tree classifier, that's what a decision tree classifier would do. Decision tree classifier would create a model like this. This is how the model would look like. The model it looks like, okay, first thing, I'm কি দিয়ে check করছি? Homeowner, right? Yes or no? What's the first attribute we're testing over here?
Homeowner.
In this example, homeowner. So if you see over here, look at this carefully. Homeowner. If the person is a homeowner, it's going to make a prediction. It's going to say he or she is not a defaulter. Is that okay, Nakina? Clear?
Yes, sir.
But if the person is not a homeowner, then it's going to check the marital status here. So if the marital status is married, it's going to classify, okay, well, he's not going to pay defaulter either. But if the marital status is either single or divorced, it's going to check with income. And if the income is smaller than 80,000, then it's going to make no. And if the income is larger than 80,000, it's going to make a prediction yes. Is that clear, Nakina? Yeah?
Yes, sir.
Right. Are we good? Okay. Now, how does it make this? Well, that's what we're going to talk. Don't worry about that. But look at this one very carefully. So what's the first attribute it checks with? So we have got three attributes. We are three attributes or features that mean the same thing. What's the first attribute that we are going to check with? Yes?
Homeowner.
Homeowner.
Now have a look here. Look at this homeowner variable, okay? Our homeowner feature. How many values can we have in a homeowner? Two values.
Two well. Yes,
Either
or no.
yes or no. Okay. Let's look at the yes. How many yeses are there? 1, 2, 3. 3 yeses. And how many no's?
7.
7 no's. Acha, for each of the yeses, what's the output? No. Correct? তার মানে it has somehow learned যে যদি homeowner yes হয় তাহলে it's always no. ঠিক আছে? But এটা হচ্ছে if we have 3 of them. And no হলে how many such instances do we have? 7, right? 2, 4, and these 3 are 7. 7 এর ক্ষেত্রে দেখো দুটো no আছে এখানে. Alright? এখানে আছে আবার yes আছে no আছে mixed up আছে আবার এখানে yes no yes আছে mixed up আছে right নাকি না so you cannot directly say no or yes because there is a mixture right so you need to split the instances again with another attribute over here is that okay নাকি না
Yes, sir.
Yes, sir.
yeah so you see this is 3 no's and 0 yes so I can say 0 yes and 3 no's so it's a pure instances means all are no so we can just say no that's it right but when we come over here how many yeses are there and how many no's are there kota yes ache 1 2 3 yeses and how many no's are there 4 no's correct nakina that's altogether 7 is that okay nakina
Yes, sir.
Yes, sir.
তারপর আমি চেক করছি কি আচ্ছা এখানে তো যেহেতু 3 yeses and 4 no's I cannot say yes or no to anybody right it's more or less equally so we need equally balanced so we need another splitting attribute which splitting attribute we have used now marital status now look at these 7 instances marital status যদি married হয় এই 7 instances এর জন্য 7 instances কোনগুলা এইগুলা এই দুটা কিন্তু বাকি তিনটা তো হয়ে গেল এই দুটা আবার এখান থেকে হচ্ছে এই দুটা চারটা আর এখান থেকে হচ্ছে এই তিনটা এগুলো আমাদের ম্যারিড কোনগুলা লেটস টেক আ ডিফারেন্ট কালার ঠিক আছে ম্যারিড কোনগুলা ম্যারিড হচ্ছে এইখানে দিস ইজ ম্যারিড ওকে দিস ইজ ম্যারিড and this is married how many married are there 3 married and for each of the 3 married what's the answer no right that's a pure class right so that's how it knows if it's married then it's definitely no yes hobe na ঠিক আছে clear নাকি না yes
Yes, sir.
okay so তাহলে these are these threes well এখানে 3 yes 4 no ছিল এখন কয়টা no চলে আসলো 3 no চলে আসলো 3 no মানে হচ্ছে 0 yes 3 no's তার মানে 3 yes ছিল এখন we still have 3 yeses left but we had 4 no's 4 no's এর মধ্যে 3 no's এখানে চলে আসলো তাহলে একটা no এখানে রয়ে গেল so we still do not have you know pure mixed up, but it's a mixed up instances right so we need to again separate it or split it using another attribute now which is the attribute we have used now here income and if the income is smaller than 80k then it knows no because all right a married gola jodi bad dei married and married egola jodi bad dei let's choose another color so we have so egola hoye gelo tale কোন গুলো বাকি রইলো এগুলা বাকি রইলো sorry this one is left single this one is left ডিভোর্স দুইটা, এখান থেকে এটা তিনটা, আর এখান থেকে এখানে চারটা। See, চারটা বাকি রইল 3 and 1 4, রাইট নাকি না? And then it figured out 80,000 এর নিচে যদি ইনকাম থাকে তাহলে it's a no, আর 80,000 এর উপর থাকলে yes, ঠিক আছে? It somehow figured out. Now we can actually do check the annual income to make a decision that whether it should be yes or no. Clear নাকি না? Is that okay? ঠিক আছে? Are we good? So this is how a decision tree looks like. ঠিক আছে? So whenever we have a data set, that's how the decision tree is going to look like, and that's how you're gonna it's going to actually make this, you know, this make this decision whether it's yes or a no. Clear? Okay. Now I haven't yet discussed তোমার decision tree classifier কিভাবে এই ট্রিটা বানাবে. We didn't discuss that yet. Don't worry about that. We will discuss that. Okay? But at least we know the decision tree classifier, the model টা তৈরি করবে, model দেখতে কেমন. Is that okay নাকি না? Yes?
Yes, sir.
Right. Okay. So far so good. Now I hope you understand why we call it a decision tree. Because doesn't it look like a tree diagram to you guys?
Yes, sir.
Data structure, remember? How does a tree look like? Yeah? Doesn't it look like a tree? Right? So this is a tree diagram. That's why we call it a decision tree. The reason why we call it a decision tree is because it's a tree diagram. And at every internal node, at every node over here, okay, which is not a leaf, we are making a decision, okay, whether he's a homeowner or not. Based on that, we are dividing, right? We're splitting. Clear নাকি না? So we are making a decision at each of these nodes over here, right? So that's why it's called a decision tree. I hope you understand so far. Is that okay?
Yes, sir.
Good.
Yes, sir.
So that's a decision tree. Now, how can you use the decision tree to make a deduction? So let's imagine this is your training data, and from the training data you learned this model. So this is the induction technique, right, Takina? Yes. Yes. What is induction? When you learn a model from the data, that process
Training
is
data set.
induction. Okay, so that's induction. So you have learned this model. Now you're going to use this model to make a prediction for a particular test data that could be called deduction. Clear, Nakina? Is that okay? So we're going to see how to deduce from the model. So let's imagine I give this test set. So this test set, if you see over here, the 11th test set we have, we do not know what should be the answer, right? But we know that this person is not a homeowner, married, and has an income of 55,000 pounds or dollar, doesn't matter. And we want to predict whether he's going to be a default borrower or not a default borrower. So we want to test this person. Okay, so that's not the same person. So let's say this is another person. Okay, so here's a profile of this person we want to make a prediction about. Okay, so this person is what? Is he a homeowner?
No, sir. Married.
No. Is he married? Yes. And he has an annual income of 80,000. So we want to make a prediction using the model, using this model, okay, of whether this person is going to be a default, is going to be a defaulter or not. So if you're using this one, you will start from the root here. So what is the first thing that you want to look into?
Homeowner.
Homeowner. So tell me, is he a homeowner?
No.
No.
No. So if it's a no, so which way you're gonna move to? You're gonna move to the right
Marital
branch.
status.
So let's go to the right branch. The no, you go to the right branch. Okay, so once you go to the right branch, now you look at the marital status. What's the marital status?
Married. Yes.
Married. So because the marital status is married, you actually know you have reached a decision that this person is not going to be a defaulter. So that's the prediction you have made about him. Is it clear, Nakina?
Yes.
Yes, sir.
Yeah. So this was not given to you. This is a prediction that you made from this model. Is that clear, Nakina?
Yeah.
Yeah. Yeah. So that's what it is. Okay, right, done. So yes, you assign the defaulted value to no. That is the prediction you have been able to make, right, from this particular model. Okay, are we good so far? So far, did you understand?
Yes, sir.
Yeah. Now it turns out that there is not a single decision tree you can make. You can make more than one decision tree, in fact. This could be another decision tree you can come up with. And this is also a valid decision tree. So in this decision tree, this is different from the earlier decision tree. Why is this different? Can anyone tell me? What's the first
That is marital
test you're
status.
going to look into? What's the first thing that you want to test?
Marital status.
Marital status.
The marital status. Okay, so you're gonna check the marital status, and based on that, you're going to make a decision. Okay, so you're using a marital status. So, for example, with the same here, what's going to happen? So it's no married 80K. So let's say this is the person comes, which is no, homeowner is no.
Sir,
Just a minute, let me make myself clear, then I will invite you to ask question. Okay, marital status and income. So for the same person, okay, all right, so this person no married and 80K. So let's say his profile is this, no married and 80K. For a different decision tree, what would be the outcome? Let's see. So the first thing we will look at is the marital status. What's the marital status? Married. So we will come where marital status is married. So which way we will go? No. ঠিক আছে নাকি না?
Yes.
Yes.
Sir.
So we simply go to no, and we have made a prediction. Done. ঠিক আছে? So this is a different decision tree, and it has also predicted no. Yeah. Is that clear? So the point that we're trying to make here is we can create different decision tree using the same data set even. ঠিক আছে? Is that clear নাকি না? Right?
yes, sir.
Yeah. So does anyone have any question? So someone wanted to ask me a question.
Sir, for the instance number 4, so
Yep.
যদি স্যার ম্যারিটাল স্ট্যাটাস যদি ইয়েস হয় তাহলে তো 4 নাম্বার স্যার ইয়েস, সো ইয়েস হইলে তো স্যার তাহলে ও হোম ওনার হচ্ছে, সো এটা 3 এর সাথে তো ম্যাচ করতেছে না, মানে এই ডাটা সেটটা।
এটা কাজ করছে না বলছো? ওকে,
হ্যাঁ
দেখি।
স্যার,
Marital status is married. Okay, so he's going to come here and it's going to predict no.
স্যার হোম
That's-
ওনার তো ইট সেজ যে হি ইজ আ হোম ওনার, মানে
তুমি কি এইটার কথা বলছো না আগেরটার কথা বলছো?
আমি এই পয়েন্টের কথা বলতেছি, মানে এটার জন্য
না, what I'm saying is এই decision tree না আগের
এই
decision tree?
ডিসিশন ট্রি
এই decision tree তে তো no predict করবে। দেখেন, what's the first thing we're gonna check here? Marital status, right? নাকি না? Yes.
Yes.
So what's the marital status of this instance?
ফর ম্যারিড,
Married হলে কোন দিকে যাব? Left hand or right hand?
লেফট,
Left, and what is going to predict?
নো sure,
No. So it has predicted no. Done. ঠিক আছে নাকি না? Clear?
yes sir,
So what was the question?
না স্যার বুঝতে পারছি,
ঠিক আছে?
মানে আমার এখানে টার্গেট ভ্যালুটা হচ্ছে ডিফল্টেড বড়োয়ারটা, সো ওইটার
Yeah,
উপর
yeah,
ফোকাস
yeah,
করতেছে। আচ্ছা,
yeah. ঠিক আছে? Okay? Right.
yes sir.
Okay, are we good so far নাকি না?
স্যার একটা কোয়েশ্চেন ছিল
জি স্যার।
স্যার, সিঙ্গেল আর ডিভোর্সকে স্যার একটা গ্রুপ করে ফেললাম কেন?
That's a very good question. We will answer that question. Don't worry. We will answer that question. আচ্ছা, so far so good. আমরা কিন্তু এখনো আপনাকে এক্সপ্লেইন করি না যে এই ডিসিশন ট্রিটা তৈরি করলো কেমনে। আমি জাস্ট দেখালাম ডিসিশন ট্রি দেখতে কেমন লাগে। ঠিক আছে? ওকে, we haven't yet spoken about how did we come up with this decision tree. ঠিক আছে? We will talk about that. Don't worry. ঠিক আছে? যখন করব তখন you will understand how did we do all those sort of things. ঠিক আছে? Are we okay so far?
Yes, sir.
Yes, sir.
Okay, good. Yeah.
একটা লাস্ট কোয়েশ্চেন স্যার, স্যার এইখানে কি প্রতিটা, মানে আমার যে টার্গেট ভ্যালুটা যেটা হচ্ছে ডিফল্ট বড়োয়ার, তো এটার জন্য কি প্রতিটা রোয়ে কি ম্যাচ করা দরকার আছে নাকি আমার
No, not at all, not at all. কারণ at the end of the day, your model is making a prediction. Prediction is not always correct. ঠিক আছে? প্রেডিকশন মানে কি, এটা তুমি প্রেডিক্ট করছো, বাট প্রেডিকশন কি সবসময় কি ট্রু হয়? সবসময় যদি কারেক্ট হতো তাহলে তো 100% অ্যাকুরেসি সবসময় থাকতো, কারেক্ট নাকি না? You never get 100% accuracy.
মানে
Clear নাকি
there
না?
will be some features যেগুলো ম্যাচ
Yeah,
করবে
there will be some at some cases তোমার রেজাল্ট ম্যাচ করবে না অনেক সময়, ঠিক আছে? অনেক সময় রেজাল্ট ম্যাচ করবে না, এই জন্য এরকম হয় না you have done some sort of test করলেন, টেস্টের রিপোর্ট আসলো নেগেটিভ, অ্যাকচুয়ালি আপনার পজিটিভ, because there is some sort of prediction that is going on there. It has predicted it to be negative, but in true it is positive maybe. Why not? So that's what is the difference between prediction and saying with certainty. Machine learning helps you to make prediction. ঠিক আছে? But what we want to learn in this course is how to make reliable prediction. এমন একটা prediction করলেন যেটাতে দেখা যাচ্ছে আপনার accuracy হচ্ছে 40%. That's not good enough. 40% accuracy means you cannot say with মানে তোমার uncertainty হচ্ছে 60%. Am I correct নাকি না? That's not a good prediction. Okay.
আমাদের আনসার্টেনটি কি স্যার, সাপোজ তাহলে মানে অ্যাকুরেসি কি অলওয়েজ 50 অ্যাবভ হলে আমি বলবো এটা বেটার?
কতর above? 50 above. স্যার মানে 50 is
এভারেজ।
it's a very little accuracy, তাই না? ঠিক আছে? আমরা we want to make predictions with as high accuracy as possible. 95%, 99%, 97%, things like that. Okay. All right.
Yes, sir.
All right, but it depends on the particular problem you're looking at. ঠিক আছে? And it depends on a lot of issues. It depends on how many, what's the size of your training set, what is there in your training set, and different other things. ঠিক আছে? We'll look into those things. But the point is, the whole point of machine learning is machine learning will give you prediction. ঠিক আছে? But we want to actually discuss how to make this prediction with very high accuracy, with high reliability, and things like that. That's basically the objective of this course. Okay, so 50% actually on a com, but you'll see. Okay, okay, you'll see later. Okay, are we good so far? So far, so good. Okay, do you guys have any other questions? আর কোনো question আছে কারো? Hello?
No, sir.
No. So far, so good? ঠিক আছে? Okay. So let's now look into the particular model that we're going to look into. ঠিক আছে? The model that we're going to make decision tree model. So the algorithm, we're going to use a particular classification algorithm. So we're going to use the tree induction algorithm. That's what we say. We have a tree induction algorithm. Okay. And we use this training set. We use this algorithm. We apply this algorithm on this training set to create this model. So this is the induction process, right? We learn the model. Now, once you have learned the model, once you have the decision tree, then you can apply this model on this test set to make a deduction of what would be the target values. Is that clear, Nakinan? Yes? ঠিক আছে?
Yes, sir.
Yeah, okay. So now it turns out, now there are a number of algorithms that can generate decision tree. There are many algorithms that develop decision trees. For example, we have something called the Hunt's algorithm. It's one of the earliest decision tree algorithm. Then we have a particular algorithm called CURT, which stands for classification and regression tree. Okay. We have algorithms like ID3, C45, Stick, Sprint, and so on. Okay. তার মানে অনেক অ্যালগরিদম আছে to create decision trees, and each algorithms create decision tree in slightly different way. Okay. Or it uses slightly different technique to actually create a decision tree. Okay. Right. So we're going to learn a particular algorithm. We're going to look into some algorithms of how to build this decision tree. Okay. So that's why I've said that you could actually have many different decision tree with the same training set. Okay, that's because it depends on which decision tree algorithm you're going to use. Is that okay, Nakina? Yeah.
Yes.
Okay. All right. Moving on.
Yes.
Now let's look at the Hunt's algorithm, and we want to see how to use this Hunt's algorithm to build a decision tree. Okay. So here's the thing that we're going to do. The general idea is this. Okay. So you've got a training set. Okay. So let DT be the set of training records that reach a node T. So DT is the training set. Okay. All right. What's the general procedure? The general procedure is if DT contains a record, so DT be the set of training records, okay, that reach a node T. Okay. If DT contains records that belongs to the same class, যদি সব সেম ক্লাসে বিলং করে, then there could be a leaf node. মনে আছে এখানে যে সব সেম ক্লাসে বিলং করছিল দেখে এখানে আমি এটাকে নো করে দিয়েছিলাম বিকজ অল অফ দেম বিলং, সবকটা ইয়েস নো ছিল, কোনো ইয়েস ছিল না হোম ওনারে, ঠিক আছে, রাইট? সো ইফ ইট বিলংস টু দ্য সেম ক্লাস দেন just make it a leaf node. But if it is not, that means a mixture of yes and no, then you have to use another attribute to split further. Okay, right? Nakina, clear? So that's what we're gonna do. Let's say, for example, here, look at this one, look at this idea. So initially, now I want you to look at this slide very carefully. A slide carefully declare up the maximum question will be answered now. Okay. Now initially, okay, how many defaulters are there? How many nodes are there, and how many yeses are there? Can you count?
3 yes, 7 no.
Okay, so we wrote over here 7,3. So prothome no likhchi tapor yes likhchi. Is that okay? So there are 7 no's and 3 yeses. Clear nakina? Is that okay?
Yes, sir.
So is it a mixture of yes and no, or it is not a mixture of yes and no? Which one?
Mixture of yes and no.
It's a mixture of yes and no, so I cannot directly say all no's or all yeses, right? So we need some sort of attribute or some sort of feature through which we want to split it further. Is that okay, Nakina? Yeah?
Yes, sir.
Yes.
Okay, so let's say we are using the homeowner as that feature to split it. Is that okay, Nakina? Yeah? ঠিক আছে?
Yes.
We're
Yes,
using
sir.
which feature to split it? We're using the homeowner feature to split it. Clear নাকি না? Okay. এখন homeowner এর value কি কি হতে পারে? Yes হতে পারে, no হতে পারে. So homeowner can be yes, homeowner can be no. Clear নাকি না? Is that okay?
Okay, sir.
Now you look at it very carefully. If the homeowner is yes, look at yes. How many yeses are there? 1, 2, and 3. 3 yeses are there. For each of the yeses, what's the corresponding answer?
Oh no.
No. If the corresponding answer is no, তার মানে কি? All are no's. That means when the homeowner is yes, then the defaulter is always no. এখানে no আর yes এর কোনো mix নাই. Clear নাকি না? Is that okay?
Okay, sir.
Right? Because কোনো mix নাই, so I can just make a decision. Okay, if the homeowner is yes, then the answer is no. Clear নাকি না? Is that okay?
Yes, sir.
Yeah. But if the homeowner is no, then what happens? If the homeowner is no, let's look at over here. If the homeowner is no, here, here, and here, how many instances are there altogether?
7.
7 instances, right? Okay. So you've got what happened? Okay. You have 7 instances, right? Okay. Right. You have got 7 instances. এই 7 instances সব কি নো বা সব কি yes? দেখেন তো কয়টা নো আছে? There are 2 no's here. Yes. And here we have got 1 yes and 1 no, right? নাকি না? Okay. And over here we have got 2 yeses and 1 no. So how many yeses are there and how many no's are there? কয়টা নো আছে? 2 no's, 3 no's, 4 no's, 4টা no আর কয়টা yes?
3 yes.
Right. So that means if the homeowner is no, then we have got 4 no's and 3 yeses. Clear নাকি না?
Yes, sir.
Yeah. তার মানে again, homeowner যদি yes হয়, if he's a homeowner, then all of them are no. So I can make a decision, it's a no, right? But if the homeowner is no, then there are 4 no's and 3 yeses. So can I make any decision? No, because this is impure, because we have got a mixture of them. So we cannot make a decision, right? Nakina, clear? Is that okay?
Yes.
So we
Okay.
need to we need to split further. But which one we need to split further? Do I need to split this one, the right one, or the left one?
Right on.
Right one. Left one to ekhone split kora kichu nei, right? So that's why, so we don't do anything with the left one, so we look at the right one. We need to split the right one further. So the right one is 4 no's and 3 yeses, if you remember. So let's now, you know, a 4 no's and 3 yes ke we split it using another attribute. And let's say this time we use the marital status attribute. Now, if we use the marital status attribute, we see a very interesting thing. If it's married, now let's see, আচ্ছা কোনগুলো আগে দেখে ফেলেছি সেগুলোকে বাদ দিই, ঠিক আছে, we'll cut them off, ঠিক আছে, এখানে ছিলাম, ওকে, এই যে দেখেন, yes, yes sir,
স্যার এখানে ইমিডিয়েট পরের ফিচারটা নিয়ে আমার করতে হবে নাকি তার আরেকটা র্যান্ডম কোনটা ফিচার নিয়ে করতে হবে?
we'll come to that, don't worry about that, okay, একটু ওয়েট করেন, বুঝে যাবেন। হ্যাঁ, দেখেন হোম ওনার যখন yes ছিল তখন তো we made a decision already, right নাকি না?
Yes sir.
Yeah, তাহলে কোন কোনগুলো আমাদের ডিসিশন নেওয়া হয়ে গেছে? হোম ওনার যখন yes ছিল এটা ডিসিশন শেষ, রাইট নাকি না? we're done with that. হোম ওনার যখন yes তখন এটা ডিসিশন শেষ, রাইট? হোম ওনার যখন yes তো এটা ডিসিশন শেষ, কারেক্ট নাকি না? yes
Yes sir.
ওকে, আচ্ছা, তাহলে আমরা বাকিটুকু কতগুলো রইলো? 3টা বাদ ছিল, বাকিটুকু কতটুকু রইলো? 7টা, right নাকি না? So that's why 4 and 3, that's altogether 7, ঠিক আছে, 4 no's and 3 yeses. If you look at it, 2 no's, 3 no's, 4 no's, and therefore definitely 3 yeses. That's altogether 7. Clear নাকি না? Is that okay?
Yes sir.
এখন এই 7টা ইনস্ট্যান্সের উপর I'm using the marital status. Now let's say marital status যদি married হয়, let's look at married for these 7 instances. So married হলে কি হচ্ছে? No. আবার এখানে এইটা ম্যারিড আছে, ম্যারিড হলে নো, এইটা আছে ম্যারিড, ম্যারিড হলে নো। সো এভরি টাইম হি ইজ ম্যারিড, ইট ইজ অ্যান্সার ইজ হোয়াট? নো। আই ডোন্ট চেক দিস ম্যারিড। কেন এই ম্যারিডটা চেক করছি না? Why am I not checking for this married? Because this has already been checked with the homeowner, right? Okay, homeowner attribute দিয়ে, ঠিক আছে না কি না?
Yes sir.
Yeah. So যতবার ম্যারিড হচ্ছে ততবার আউটপুট কি?
No.
No. তার মানে can I say marital status যদি married হয়, then what's the output? Output is no. So we make a decision here that the output is no. Is that clear নাকি না?
Yes sir.
So if the marital status is not married, তাহলে it can be single or divorce. So আমি তাহলে marital status married এর জন্য শেষ। So married এর জন্য শেষ মানে হচ্ছে এই ইনস্ট্যান্সটা বাদ, এই ইনস্ট্যান্সটা হয়ে গেল, এই ইনস্ট্যান্সটাও শেষ হয়ে গেল, এই ইনস্ট্যান্সটাও শেষ হয়ে গেল। তো বাকিটুকু কতগুলো রইলো? এই যে সিঙ্গল অ্যান্ড ডিভোর্স। marital status single but divorced হলে then it goes here. Now if you see for single and divorce, 1 no, 1 yes, 2 yeses and 1 no, 3 yeses, 1 no. So you see when you come here, you've got 1 no and 3 yeses. Clear নাকি না? So এখানে তো we made a pure decision because there are 3 no's and 0 yeses, so we made a decision. But এখানে কি আবার mixed up আছে না নাকি না?
Yes sir.
Hello? এখানে mixed up আছে, right? So we need to actually use another attribute to split this further, okay? And then in order to do that, the other attribute that we use is the annual income. ঠিক আছে? Okay? আচ্ছা, clear? And now we see, okay, একটু ভালো করে দেখি কোন কোন ইনস্ট্যান্স গুলা। ইনস্ট্যান্স নাম্বার 3 আমি একটু লিখে রাখি, বাকি আছে ইনস্ট্যান্স নাম্বার 3, 5, 8 and 10, right? So chapter instance, you see chapter 1 and 3 altogether, 3, 5, 8, 10. So I'll write it down here, 3, 5, 8, and 10. So we want to now look into these 4 instances, which are instances 3, 5, 8, and 10. So let me highlight them. So this is instance number 3. This is instance number 5. This is instance number 8. Okay. And this is instance number 10, right? Nakina, clear? Okay. এখন এই ইনস্টেন্স নাম্বার 3, 5, 8 and 10 এর মধ্যে কতগুলো নো আছে, কতগুলো ইয়েস আছে? সো ইফ ইউ সি নো, ইয়েস, 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 3 yeses, 1 no, তার মানে যখন এখানে ছিলাম we had 1 no and 3 yeses. Clear? And now এখানে আমরা আছি, so 1 no's and 3 yeses. So I'm splitting it further with another attribute. Which attribute have I used this time?
annual income.
Annual income. এবং annual income, remember, it's a continuous variable here. And we check smaller than 80k. আচ্ছা, তাহলে প্রথমটা দেখি, is it smaller than 80k? প্রথমটা
Yes.
এই চারটা দেখবো, smaller than 80k. এটা কি smaller than 80k?
হ্যাঁ স্যার।
Instance 5
Oh,
smaller
five.
than 80k?
No.
No স্যার। Nine,
Instance 8 smaller than 80k?
No
No.
স্যার।
And instance 10 smaller than 80k?
No স্যার।
না, তার মানে smaller than 80k কয়টা ইনস্ট্যান্স আছে?
একটা।
একটা। এবং what's the output?
No.
Right. So smaller than 80k, there is only one instance, and that is no. Clear নাকি না? Is that okay?
Yes sir.
And larger than equal to 80k কয়টা আছে? এটা একটা, this is larger than equal to 80k, this is another one, this is another one, and এই প্রত্যেকটাই কি?
Yes.
Yeah, so that means smaller, greater than equal to 80k, প্রত্যেকটা yes, so we would predict it as yes. Is that clear নাকি না?
Yes.
Yes, this is how the Hans algorithm builds this particular, decision tree. Now, I know there's a lot of questions that can come over here, that can arise in your mind. Let me ask some of the questions, or let me just point out some of the questions that may arise in your mind. Okay? If you have any other question that arises in your mind, feel free to add it up after I've said that. Okay? The first question that may arise is, how did the algorithm decide what's the first, attribute to choose? Why did we use homeowner to split first? Why did we not use the marital status to split first, or the annual income to split first? Right? That's one question we need to look into, right? Second question, you guys have said, but second question that could arise is here. Why did we split the marital status into two parts? Okay, married and single divorce. Why not into three parts, single, divorce, and married? That's another question that may arise. The third question may arise is, okay, when we're splitting with annual income is a continuous variable. How did we figure out this 80k thing? 80k idea ta kotha theke ashto? Clear naki na? Is that right naki na? How did we figure out, okay, let's look at all those instances, who have an annual income of below 80k or larger than equal to 80k. How did that arise, right? These are some of the interesting questions that may arise, right? Do you have similar questions in mind? Any other questions do you have in mind? Hello?
So what if default valueটা স্যার মানে যখন এখানে যেমন আমরা হোম ওনার ফার্স্টে চুজ করতেছি, তারপর এইভাবে করে যে চুজ করছি, হোয়াট ইফ সবগুলো ভ্যালু যদি মিক্সড আপ থাকতো, ইটস লাইক ফার্স্ট একটা ইয়েস তারপরটা নো, ইয়েস নো, ইয়েস নো, এইভাবে করে যদি থাকতো,
still your decision tree would be able to maybe the tree will become complex, but it should be able to come up. It will be complex, it will be more longer, এগুলো হতে পারে, but it should be able to come up with the decision. Okay, yeah, is that okay naki na?
yes sir.
So these are definitely some questions that we need to look into. Okay, all right, so here are the design issues of the decision tree induction. First of all, how should the training records be split? How am I splitting the records? Okay, which attribute am I using to split it? Okay, right? Okay, this is a very, very important question. Okay, how should the splitting procedure stop? Shall I stop the splitting if all the records belong to all the classes, belong to the same class? Okay, that's a pure. Or do I make an early termination? এখানে mixed up আছে, but ওখানে it's like 7-1 is so small that we just make a decision. Do we do an early termination, or when do I stop splitting? Okay, what if you have a very complicated data set, and the decision tree keeps on growing and growing and growing. Okay, Where do I make the stop? So that's a very interesting question as well. Okay, sir. So we need to think about these design issues when building this decision tree. Is that okay, Nakina? Clear? Yeah. Hello.
Yes, sir.
Okay.
স্যার
Right.
আমরা যদি ডিফল্ট ভ্যালু যদি কোনো না পাই তাহলে কি এটা কন্টিনিউ হইতে থাকবে?
Sorry, say that again.
আমরা যদি স্যার ডিফল্ট ভ্যালু না পাই, ফর এক্সাম্পল ফার্স্ট অফ অল হোম ওনার
Default borrower, you mean?
হ্যাঁ হ্যাঁ, মানে সাপোজ ডিফল্ট বরোয়ারটা যেমন আমরা হোম ওনারের ক্ষেত্রে যখন আমরা
No,
দেখতেছি
no,
যে
that's the design question. এটাকে আমি কি ডিসিশন ট্রি গ্রো করতেই থাকবো নাকি shall I stop somewhere? ঠিক আছে, all these are very interesting design questions.
এখানে তো স্যার আমরা একটা ডিফল্ট ভ্যালুতে যেয়ে তারপর স্টপ করেছি।
Yeah, so that's what I'm saying over here.
Yes.
How should the splitting procedure stop? Should it stop the splitting if all the records belong to the same class, okay, or have identical attribute values, or if it keeps on growing and growing, আমি কি decision tree grow করতে থাকবে, or do I make an early termination? How do I ensure when to stop and when not to stop, right? That's a design question, and we will address this question. How do we make such decisions? Clear, Nakina?
Yes.
Yes?
Yes.
That's what you are asking, actually. Okay, so now let's see. First of all, let's look at different attribute types. Like binary attribute, nominal, ordinal, and continuous. এবং এক এক ক্ষেত্রে কিভাবে split হয়. Let's look at this one. Okay. All right. So first of all, I could split multi-way, or I could make a binary split. For example, marital status. Marital status in your training set, quite a specific values ache. How many possible values are there in the marital status?
3.
3. So shall we do multiple split? Like, okay, marital status single, divorced, married. এভাবে যাব? নাকি do we go for binary split? Like marital status, married হলে দেখি, single divorce হলে দেখি, বা single হলে এদিকে দেখি, বা married divorce হলে দেখি, বা আরেকটা কম্বিনেশন তোমার single and married এদিকে দেখি, divorce এদিকে দেখি. So there are many options you have. You could do multiple split, you can do binary split. Binary split করলে, you know, if you have multiple values, কিন্তু binary split করলে you have to combine two of them. তাই না নাকি না? Is that right? Okay, combine করলে কোন দুটোকে combine করব? All these are design questions we have. Okay, right? So some other examples here. Is that okay? Is that question clear, Nakina?
Yes, sir.
Right. Another question to look into is for the ordinal attribute. Now, do you remember the difference between nominal attribute and ordinal attribute? When is the data called nominal data, and when is the data called ordinal data?
Sir, when the data does not have any chronology among them, that's
Good, very good. So basically, if you remember, you have a data. Your data could be discrete or continuous. Am I correct, Nakina? Yeah?
Ordinal data has
Yes.
ordering.
Yeah, right. Sashi, continuous, or your data could be discrete. Clear? এটুক ঠিক আছে নাকি না? Yeah? Hello?
yes, sir.
And discrete data is sometimes also called the categorical data, right, Nakina? If your data is a discrete or categorical data, I can further divide. This is a nominal data, or it's a ordinal data. Okay? আচ্ছা, nominal data মানে হচ্ছে যেমন for example marital status. Marital status এর values গুলো কি কি? What are the values we have here? What are the possible values of this marital status data?
So
Single,
divorce.
Divorced, married. Now, এটা কি এদের মধ্যে কি কোনো order আছে? No. They don't have any specific order, right? They can be in any order, right? They don't have anything larger than the other. এরকম কোনো order থাকা মানে কি? Order থাকা মানে তাদের মধ্যে কোনো greater than equal to বা smaller than equal to relationship আছে, right? Do they have any such relationship? They don't. Clear, Nakina? Is that right, Nakina? Yeah?
Yes,
Nobody can
Yes,
say
sir.
single is smaller than divorce, which is smaller than married, or greater than equal to divorce, greater than equal to married. No such relationship exists. So that's why this is a nominal attribute. Okay, because marital status, is it discrete or continuous? First of all, in this example,
It's
it's
discrete.
discrete, and therefore it could be nominal or ordinal. In this example, it is nominal, right? Let's take an example of an ordinal attribute. Let's say chart size of the chart. Okay, and let's say the categories that you have are small, medium, large, and extra large. Now, surely this is discrete, right, Nakina? So chart size is what, categorical data or continuous data?
Categorical.
Categorical data or discrete data. But categorical data হলে এই data এটা তোমার nominal হতে পারে, ordinal হতে পারে। এখানে কি এটা কি nominal না ordinal? What do you think?
Ordinal.
Ordinal. Why is it ordinal? Now you see there is a particular relationship, smaller than equal to or greater than equal to relationship. Small is smaller than medium, medium is smaller than large, large is smaller than extra large. Right, Nakina? Clear? Yep. So that's why it's an ordinal attribute. So chart size is an ordinal attribute. Yes? Clear, Nakina?
Yes, sir.
Okay. Now, because it is an ordinal attribute, now we can divide the chart size many ways. We can do a multiple split. So we have 4 different values. Or তুমি যদি multiple split করতে চাও না, তুমি ধরো binary split করতে চাও। Binary split করলে দুটো, তার মানে you have to group them. So maybe you can group small and medium here, large and extra large here, অথবা small here, medium, large, extra large here. Is that okay, Nakina? Clear?
Yes, sir.
Or you could do small and large here, medium and extra large here. But if it's an ordinal attribute, you should preserve the order property among attribute values. That means small and medium is smaller than large and extra large. Is that order property preserved here?
Yes, sir.
Yeah. Again, over here it's also preserved because small is smaller than medium, large, and extra large, right, Nakina?
Yes, sir.
What about here? Can I say this is smaller than that?
No, sir.
No, because yeah, I guess small is smaller than medium, fine, but large cannot be smaller than medium. So when you're grouping small and large into one category, then this order property is not preserved. So if you are doing a binary split for ordinal attribute, you should take extra caution in order to make sure that it preserves the order property among the attribute values. Is that okay, Nakina?
Yes, sir.
Yeah. So that's an important thing you need to consider. Okay. Right. So we just discussed that. Okay. Now, what about how do you split continuous attributes? Let's say, for example, annual income. Annual income is a continuous attribute. Now, you can also split it in many ways. You can split it using a binary split. So we have seen in this example, we have used a binary split here, right? So annual income larger than equal to 80K or smaller than 80K. So that's a binary split, right? So we could do binary splits like this way. Annual income larger than equal to 80K goes here, smaller than 80K goes there. Or we could do multiple splits. For example, smaller than 10K, 10K to 25K এখানে, 25K to 50K এখানে, 50K to 80K এখানে, 80K above এখানে, right? We could do that as well. Clear Nakina? Right? We could do many techniques over here, right? So that's for the continuous. So we could do binary decision, okay, or we could do multiple split by finding equal interval bucketing, ঠিক আছে, by equal frequency bucketing, percentile, first 25%, second 25%, third 25%, and the last 25%. We could do those sort of things as well. Clear, Nakina? So there are many ways we could split. We could split in discrete, binary split, or we could actually use multiple splits. ঠিক আছে? Is that okay, Nakina? Okay. Now that we know that we can split continuous values, we can split discrete values and stuff like that. Here's the very important question we have: how to determine the best split? which one is the best split. Okay, so here is an example. Look at this one. How many data set do we have here?
One data set, sir.
Sorry,
One data set.
20.
data
Oh.
set is one. Okay, that's right. How many records do we have? How many instances do we have?
20.
আচ্ছা, এখন এখানে কতগুলো ফিচার্স দেওয়া আছে বা কতগুলো ইয়ে আছে বলেন? How many features are there?
3 features on
features, sir.
target
Actually,
level.
actually, it should be 3 features, right? Nakina, which are these 3, right? Okay. Customer ID essentially should not be a feature, okay? But in any case, we just kept it there, right? And depending on the gender, the card type, and the shot size, you are, classifying that group as belong to class 0 or class 1. Is that okay? Now, surely, if you're using a decision tree to make a decision, we could split first of all using a gender. I could do that. I could split using a card type. Okay, right? I could do that. Okay, or I could split using shot size. Okay, I could do that. Okay, well, if you want to split using a customer ID, if you want to incorporate it, you can do that as well. So there are many ways or many attributes by which we can split it. Clear na kina? Here's the first question. যে নোডে যে প্রথম যে স্প্লিট করব, স্প্লিটটা কোন পার্টিকুলার অ্যাট্রিবিউট দিয়ে স্প্লিট করাটা বেস্ট? Is it the customer ID? Is it the gender? Is it the card type? Or is it the shot size? What do you think?
তো যেটা বেশি অ্যাকুরেসি দিবে একেবারে শুরুতেই।
Okay, right. That's actually something we need to look into. Okay, all right. So we are going to discuss how to determine this best split. Okay, best split থেকে তোমার split হবে, তারপর further split কিভাবে করব? Let's discuss this in the next class, and that's when we are going to discuss exactly splitting গুলো কিভাবে হবে এবং decision tree কিভাবে grow করতে থাকবো আমরা, ঠিক আছে? And we will also discuss questions like কোনখানে এসে we will stop and stuff like that. Is that okay? So basically you understood what a decision tree looks like. Let's discuss in the next class, how does this algorithm work? How do we build a tree from a training set? Is that okay, Nakina? Clear?
Okay, sir.
Yeah. Does anyone have any questions? If no, I can stop the recording. So does anyone have any questions from what's going on today? No? I guess then I'll just stop the recording.